You are welcome to my YouTube channel. Our topic for today is trigonometric function of angles of any magnitude. Compound angles. To demonstrate this, consider the following figure. P, R, O, N, Q. Hence, we see that cos A plus B will give us cos A cos B minus sin A sin B. Similarly, cos A minus B will be equal to cos A cos B plus sin A sin B. Again, sin A plus B will be equal to sin A cos B plus cos A sin B, while sin A minus B will give us sin A cos B minus cos A sin B. These are called trigonometric identities. Let's look at some examples involving compound angles. Example, find A sin 330 degrees, B cos 240 degrees, C sin minus A, and D cos minus A. Solution to A is sin 330 degrees will be equal to sin 360 minus 30 degrees. Since sin 330 degrees is in the fourth quadrant, you can split it by saying 360 minus 30 degrees and will still give us 330 degrees. So using our trigonometric identities, we are going to have that sin 330 degrees will be equal to minus 1 over 2. For B, cos 240 degrees is in the third quadrant. Therefore, you say cos 180 degrees plus 60 degrees will give us cos 240 degrees. And when you use the proper trig identity, you're also going to have minus 1 over 2. For C, sin minus A can be written as sin 0 degrees minus A, which will be equal to sin 0 cos A minus cos 0 sin A. And we know that sin 0 is 0, while cos 0 is 1. So when you simplify properly, you're going to have that sin minus A will give us minus sin A. Similarly, for cos minus A, it will be the same as cos 0 minus A, which will give us the trig identity there will be cos 0 cos A minus sin 0 sin A. And we know that cos 0 is 1, but sin 0 is 0. So with proper simplification, cos minus A is the same thing as cos A. Multiple angles. The formula for compound angles can be used to find the values of multiple angles. For example, angle B is made equal to angle A. Hence, instead of having sin A plus B, you now have sin 2A, which will be equal to sin A plus A, and which will simplify to 2 sin A cos A. So the trig identity for sin 2A is equal to 2 sin A cos A. Similarly, the trig identity for cos 2A will be cos square A minus sin square A. And cos square A plus sin square A is always equal to 1. Let's look at the trig identity for tan 2A. Tan 2A, it will be equal to 2 tan A all over 1 minus tan square A. So higher multiple angles can be found by building up on the results already found. Let's look at some examples involving multiple angles. Find the formula for the following. I sin 3A, I cos 3A. Solution to I is that the trig identity for sin 3A is equal to sin 2A plus A, and when you split that up, you're going to have sin 2A cos A plus cos 2A sin A. And with proper evaluation and simplification, you're going to have that sine 3a will be equal to 3 sine a minus 4 sine cube a. Therefore, sine 3a is equal to 3 sine a minus 4 sine raised to power 3a. For II, cos 3a will be split into cos 2a plus a, and the trig identity for cos 2a plus a is cos 2a sine a minus sine 2a sine a. And when you evaluate properly, you're going to have 4 cosine cube a minus 3 cos a. Half angles. Half angles can be substituted in the compound angle formula. For example, sine A can be split into two half angles, A over 2 plus A over 2. So you now have that sine A will be sine A over 2 plus A over 2. And that will break down into 2 sine A over 2 cos A over 2. Similarly, the trig identity for cos A now will be equal to 1 minus 2 sine square A over 2. And for tan A, you're going to have 2 tan A over 2 all over 1 minus tan square A over 2. A useful substitution can be derived by expressing the trigonometrical ratios in terms of tangent of a half angle. Here, sine A will be equal to 2 sine A over 2 cos A over 2. Although, by the time you divide through the expression there by cos square A over 2, we are going to have that 2 sine A over 2 cos A over 2 all over sine square A over 2 plus cos square A over 2 will break down to having 2 tan A over 2 all over 1 plus tan square A over 2. However, when you put tan A over 2 to be t, so anywhere I see tan A over 2, I represent it with t, you are going to have that sine A will be equal to 2t all over 1 plus t squared. Similarly, cos A will give us 1 minus t squared all over 1 plus t squared, while tan A will give us 2t all over 1 minus t squared. These are called the t formula, where t is equal to tan A over 2. Let's look at some examples involving half angles. Example, if tan A is equal to 24 over 7 and theta is acute, calculate tan theta over 2. Solution, with t equal to tan theta over 2, we have that 2t over 1 minus t squared will be equal to 24 over 7. That is, when you do your cross multiplication and try to make t the subject, you are going to have this quadratic equation and try to collect like terms. You are going to have 24t squared plus 14t minus 24 equal to 0. And that will give us a quadratic equation which can be factored out into 4t minus 3 in bracket 3t plus 4 equal to 0. And going forward, you're going to find that t will be equal to minus 4 over 3, or t is equal to 3 over 4. But since theta is acute, so is theta over 2. So that tan theta over 2 is positive. Therefore, we'll have tan theta over 2 to be equal to 3 over 4. So we are going to discard the one that have negative number. The factor formulae. Using the compound angle formula, the sum of two sines can be written as sine A plus B plus sine A minus B will give us sine A cos B plus sine cos A sine B plus sine A cos B minus cos A sine B. And when you evaluate and collect like terms, you're going to have 2 sine A cos B. Now let A plus B be represented as x and a minus b be represented as y. Then you're going to have that x plus y will be 2a. Therefore, our a, when you make a the subject there, will now be x plus y over 2. And our b will be x minus y over 2. Now, substituting the values of x and y for a and b, we are going to have sine x plus sine y will be 2 sine x plus y over 2 cos x plus minus y over 2. Similarly, sine x minus sine y will give us 2 cos x plus y over 2 sine x minus y over 2. Again, cos x plus cos y will give us 2 cos x plus y over 2 cos x minus y over 2, while our cos x minus cos y will be equal to minus 2 sine x plus y over 2 sine x minus y over 2. So we are going to bear this factor formula in our mind as we navigate through this course. Another example, should express 2 sine 2 theta cos 5 theta as a difference between two geometrical ratios. Solution, we are going to pick one of the formulae which says sine x minus sine y is equal to 2 cos x plus y over 2 sine x minus y over 2. So that is the identity we are going to choose, and when we do that, we will represent x plus y over 2 with 5 theta and represent x minus y over 2 with 2 theta, and therefore x plus y will give us 10 theta while x minus y will give us 4 theta. So we'll call them equation 1 and equation 2. Adding the two equations together will give us that x will be equal to 7 theta, while subtracting the two equations together will give us y equal to 3 theta. So substituting that into our formula, factor formula method, we are going to have that 2 sine 2 theta cos 5 theta will simplify to sine 7 theta minus 3 theta. Thank you for watching.